Okay, the robot config abstract class is actually um, is inside of the lib folder under team 3061 is where that resides. Um, because again, this is the class that doesn't change um, much from year to year, whereas the classes that extend it are all down here inside of the configs folder where the current year code is. We're not going to go through all of this, but I did want to give like a quick overview here. It's an abstract class as a singleton, so there is a static get instance method which will return the current robot config. And you may remember inside of robot container, one of the very first things we do inside a robot container, actually the very first thing we do in robot container is to construct the appropriate subclass of robot config based on the specific robot on which the code is running, which is determined by in the constants file. So there's a lot of methods here. We've tried to document them pretty well. They relate to everything from do you have Phoenix Pro to different constants for PIDs and feed forwards for your swerve, to CAN IDs for your drive motors, your steer motors, your encoders, your steer offsets, your gyro, physical attributes of your robot, track width, wheelbase, wheel radius. This is really important to get right. We'll talk more about that later. Your kinematics object, whether for swerve or differential, the positions of all your swerve modules physically on your robot, where all your cameras are. Actually, this isn't camera, right? We're still in physical properties. Robot width, length with bumpers, all sorts of stuff about cameras. What are the robot to camera transforms? That says specifically where your cameras are located on your robot. Um, we'll talk more later about how we have a feature that lets us calibrate those robot to camera transforms. And so there's some poses involved in that. The standard deviation for your vision pose estimates, robot max velocities of different sorts, um, PID constants for autonomous, for driving and for turning. So many things here. The path planner robot config, which is used to create the optimized paths in path planner. More physical properties: mass, moment of inertia, coefficient of frictions, camera names, the CAN bus name. So if you're using Canivore, CanFD, empty string is just the RoboRio bus. Otherwise, the string corresponds to the name of your Canivore bus. Things for pneumatics, drive to pose specific constants. We'll see where those are used later. Lots of different options here. So that is what all of this is about. And so inside of here, we have a default robot config file with a bunch of fix me comments in it that kind of steps you through like, okay, so you're making your own robot using 3061 lib. You need to review all this stuff. Here's like what you need to update and how it works and all of these types of things. Because the values that work for a robot for any given year won't necessarily work for a robot for any other year. So this is something that needs to be reviewed and updated every year. So that's why we, for example, have different config files here for our competition robot versus our practice robot and things like that. So, and you'll notice like for things like, um, the vision test platform that I referred to earlier, um, you really only need to specify and override those methods that you care about. So we care about like the robot to camera transform for using this. We care about the camera name, which are defined as constants up here. And then there's a couple other things we override because we either have to, because of the abstract class, but we just leave empty because we don't have a swerve drivetrain, for example. So that is the config subclasses and the robot config abstract class.